Hello everyone. In this video, we are going to see about a project titled as Automatic Urinal Flush Controlled Excretory Health Monitoring System using urinary analysis, presented by myself Subramanian here and Darun B. Hariprakash R of final year Triple B Sri Ramakrishna Engineering College, Coimbatore. Our mentors are Mr. Marisekhar B and Dr. Aliran S. The start of the journey for this project inculcated from three parts. One is hostile urinals, and another one is a home scenario of one of the team member in which a old man faced lot of health crisis and lot of troubles in analyzing his urine samples. And another part is troubles faced in workspaces because of poor excretory health. These three parts, that is the three stories, made a reason to start this project. Our body consists of 10 types of systems, starting from muscular system, skeletal system, and ending with circulatory system. The excretory health is very much important, and the excretory health is directly or indirectly deciding the health factor of a human being. What are the problems faced from those three incidents are poor hygiene, intolerable smell, spreading of communicable diseases, and accumulation of insects and microbes, decreased excretory system health. Diseases caused because of poor excretory health observed in those three parts of the journey are dysuria, urinary tract infections, and bacterial infections from the stakeholders of those three journeys. Mindset of the target people are irritating. They easily get angry at everyone who are at their vicinity, and some viral diseases are happened for some persons. They felt helpless. The target consumers for this project are old age people, workers at a particular workspaces, that is a group of 10 to 15 people working at a particular workspace, and hostelers. After going through so many literature survey, we found that we have to develop a system by analyzing the customer needs, by detecting the health status of the urine sample, and to clean the environment of the urinal, and to improve the hygienic practices, to develop a feeling of satisfied and protected from diseases, and to improvise the health status by using smart ICT technologies. The existing system only used in foreign countries are laboratory attachments, and it costs very much and not affordable for everyone. It is implemented with luxurious toilet accessories itself. Some research-based prototypes are developed in advanced level. The identified issues in existing system are price, non-robustness for all places, big and luxurious attachments, and not compact for everyone. Thus, the solution to develop is so much adaptable, operable, reliable, user-friendly, and ethical according to the law. While going through the literature survey, we found that the excretory health can be easily predicted using hydration level of the urine sample by analyzing its color, and the pH level of the urine, and density of the urine, chemical composition of the urine sample. So the solution of this project includes the detection of user presence, collection of the urine sample, analysis of the collected sample, publishing the results privately to the user, and automatically it flushes itself by using a cleaning setup. The architecture of the system is explained in this slide. First, the user is authenticated using RFID tag cards. It is processed by using the control unit, and then the sample collection module starts collecting the urine sample, and the health data is stored in the data storage unit, and it is transferred to the cloud unit. This in turn transferred to the mobile phone or wearables of the user. After all this process, the automatic flushing unit starts to work on, and it flushes the urinal using cleansing solution. This concept mock-up 3D sketch of the idea depicts the solution. Whenever the user urinates, the urine sample is collected using this retractor. As of now, the retractor is 3D modeled and yet to build upon. The ultrasonic sensor identifies the user presence, and the RFID reader reads the reader data. After the sample taking process completed, the automatic flushing unit cleans the urinal. This is the sample wearable app framework that we have ideated, and this is the sample mobile app framework which is going to be implemented in future. At present, we are only prototyped the user authentication and sample analyzing system. Closed loop feedback IoT enabled system is implemented using TCS 34725 color sensor, pH sensor, soil moisture sensor, DST level sensor, servo motor, mini water pump, and peristaltic pump, 3D printed retracting mechanism enclosure, and LCD display node MCU1 with transparent water tubes with solenoid valve. This pie chart depicts the cost estimation of all these parts with a budget of 10,000. At present, we are only used the conductivity sensing sensor and temperature sensor. In future, we are going to use the TCS color sensor and the pH sensor. This is the retractor sketch that we have modeled in SolidWorks. This is going to be 3D printed for collecting the urine sample from the user. This video depicts the sample prototype. This is the 3-cell lithium power bank, and this is the normal power supply. Using both of the power supplies or any one, the project can be operated. This is the Arduino sketch developed for this project exclusively. This is the transformer 220 bar 12 volt DC transformer used to convert the AC to DC, and this rectifier converts the DC for this prototype. This node MCU analyzes all this data and process and acts as a processing unit. This conductivity measuring sensor and the temperature sensor collect the data and send the data to LCD display and also node MCU. After starting up, this module tries to connect to nearby Wi-Fi network. After connecting to the Wi-Fi network, it starts scanning of valid ID card. If a user named as Ram uses his RFID card, the system greets him and starts analyzing his urine sample, and the results are published. And it shows high salt content, drink more water. And then it starts for another user named as Kumar. The results are published. This is the feedback. It is indirectly or directly given to the user himself or herself. If the same user urinates once again in the same urinal, it greets him and starts analyzing the urine sample, and it identifies the salt content, and the count number is increased from 1 to 2 since he urinated once again. Since the urine content is health, there is no feedback given to the user in LCD display. In future, we are going to implement this sample retracting motor module with this Arduino sketch. This is the small prototype that we have implemented as of now. This is the some snapshots of testing of the prototype. This web-hosted app indicates the temperature and the salt percentage of the users. This graph depicts how the salt content is varied throughout the time. This is for Ram and this is for Kumar. The user can track their excretory health in their meantime, and the feedback is automatically given by the system itself to the user. Thus, the user can track their body health by analyzing their urine at their own cost. They can avoid some diseases like migraine, kidney failure, kidney stones, diabetes, dysuria, and blood pressure. An external communication module can also be used to send the health data of the user to their devices. In future, this external communication module can also be used to send the health data, to the healthcare taker, that is the user's family data, for further analysis. And also there is a scope for cloud-enabled AI model for proposing health-based prediction on data gathered. Thus, the proposed system is expected to offer daily health monitoring and helps in yearly disease prediction. This is the project plan. As of now, we have completed the brainstorming, and the software level starting level simulation is implemented. Small level POC is developed. In future, we are going to implement all those subsystems and finally test this complete setup and fine tune according to the results. Thank you.